Okay, here we're going to look at questions on the sine rule. So first of all, what is the sine rule? Well, sine rule enables you to find missing sides and angles. So the sine rule helps to find missing sides and angles of non-right angle triangles. Okay, so typical triangle might look something like that. And you can label the triangle with capital letters for your angles, A, B, C. And opposite each angle are the small letters corresponding to the sides. And you should get into the habit of labeling triangles in that way. And now we're going to look at an example. So here's an example of finding a length for the sine rule. Now, if we're finding a length, it's helpful to remember the sine rule for lengths. And to do that, we remember that the A over the sine of the angle A is B over the sine of angle B, which is C over the sine of angle C. So this is for missing lengths. So we make sure whatever we're trying to find, if we're finding a missing length, then our lengths go on the numerator of this formula over here. So the first thing we want to do really is to label our triangle. So let's say we could just call this A, and this is capital A, and we can write capital A here, B, C, and this is B, and this is C. You can see here that our triangle that we are trying to find x on is involving this length, which we're calling A, which is actually x, this unknown x that we're trying to find, and the B, the angle B, and the angle A. So we want to substitute those pieces of information into that formula for the sine rule. So we're going to start off with our A, that's our x that we're trying to find, divided by the sine of the angle that's opposite to that. And remember, this is our A here, 64 degrees, so that's the sine of 64 degrees, is equal to, and now we've got our side B, which is 11, divided by the sine of the angle opposite, which is 104 degrees. But we want to get x on its own, so we're going to multiply both sides here by the sine of 64 degrees, and multiply here by the sine of 64 degrees, and therefore we get x is equal to 11 over sine 104 times 64 degrees. And we're going to put that into the calculator now. So we have 11 divided by the sine of 104 degrees. Now I'm just checking that this calculator is in degrees, which it is, so that's fine. And I'm going to multiply that result by, the sine of 64, beg your pardon, I should have written the sine of 64 there. The sine of 64. Let's execute, and we get 10.19 to two decimal places. 10.19 centimeters to two decimal places. And you should always look at your answer to say, is it sensible that that is 10.19? Yeah, it seems it's in line, certainly in line with the fact that this is 11. It's not a right angled triangle, so we're not expecting it to know whether or not it's slightly more or slightly less than this 11 centimeters here. However, there is one little trick that we should remember, that the angle opposite the side opposite the largest angle is going to be the longest. So this side here, 11, which is opposite the 104 degrees, will be larger than the side opposite the 64 degrees. And therefore we should expect our answer of x to be less than 11, and therefore 10.19 seems to be a sensible answer. Okay, let's find another question now. Major questions here. So let's try this angle question. So let's just take a screenshot of this one. Try this question here. And this is for finding a missing angle. Now, for finding a missing angle, it's sensible to have the formulae with the angles on the numerator. So before we do that, we're going to label our triangle again. So perhaps this is A, B, C. This is our B opposite our angle B. This is C opposite our angle C. And this is A opposite our angle A. And we're going to say that we want our angles to be on the numerator. So we're going to have the sine of A over A is the sine of capital B, which is the sine of capital C over C. And we're going to involve the angle A, this one, the other angle that we know, which is C. So we're going to form an equation involving this term here and this term here. So we have the sine of my angle A, and the angle A is y, that's the thing that we don't know, divided by my length A, which is 5, equals the sine of C now, so that's the sine of the angle C that I know, which is 53 degrees, divided by the opposite side, which is 7. Let's see. We're going to try and get y on its own here, so the first thing to do is perhaps get rid of the 5 on the denominator by multiplying both sides by 5. So we get the sine y is sine of 53 degrees over 7 times 5. And if we want to, we can work out that value now. So we get the sine of y is equal to the sine of 53 divided by 7 times 5. Sine 53 divided by 7 times 5. And we get to 0.5705. 0.5705 to 4 decimal places. Now, that's the sine of y. Well, to actually find out what y is, we need to find the inverse sine. So we do the inverse sine, both sides, and we get 0.5705 there. So we want to calculate the inverse sine of that, so we do shift sine, and we're going to use the answer button because that contains our 0.570539 answer. And we get an angle of 34.78 degrees. That's our 34.78. Does it look sensible? Yeah, it looks sensible. It's going to be smaller than 53 degrees by virtue of the fact that 7 is longer than 5. So this angle, its opposite side, this is going to be smaller. So 34.78 is definitely smaller than 53. So I seem to be happy with that. That's the sine rule. Now, let's just have a quick discussion about when you might use the sine rule. You use the sine rule when you know at least one pair of side and opposite angles. Okay, remember that you need to know at least one pair of side and its opposite angle in order to use the sine rule. If not, cosine rule.